All right. So as you heard in the introduction, I am trained as a geologist and I study past climate and sea level change. And so I'm going to share with you some of what I've learned about that over the next half hour. And I'm going to spend the first part talking just about climate change and the evidence for that and so forth a little bit to set the stage. And then talk to you about the research that I do looking at past sea level changes in Earth's history and what that tells us about what we can expect in the future, right? That's essentially my line of work. Okay. So I always like to start with the basics of climate change so you can understand the context and the motivation for the work that I do. Many of you may have seen an image that's very popular now. They're called global warming stripes, and it ranges from blue kind of stripes on the left to red stripes on the right. And what it's trying to show you is how temperature has changed from the late 1800s, when it was cooler, up to today. And I often show it as this color image because it's really visually impactful, and you can really see that more recently temperatures have increased and increased by a lot, right? So if you look back at the year that I was born, we've been doing nothing but just going up in temperature since then, right? So that's the context of what we're living through today in terms of climate change. Now, when you hear about sea level rise in the news, oftentimes you see pictures of ice sheets or polar bears and people talking about those things, which is all fine and well, but it makes it feel like the problem is really far away, right? It's in the polar regions and it's affecting the polar bears. And what does this have to do with me? And I don't think that's a particularly effective way of communicating, understanding, how this is going to impact our lives. I prefer to use images that literally puts humans into the picture. And so if you go back and look at this later, the slide that's showing right now has people standing in water, some of them up to their knees, some up to their waist. And for each person, they're standing in the depth of water of how much sea level is going to rise over their expected lifespan in the place where they live, right? And what this gets across is that this is a problem that's happening today. It's going to impact us in our lifetimes, regardless of what age you are, whether you are young or old, right? Climate change is already affecting us, and as is sea level rise. And so I think understanding that how this, impacts us in the places where we live is a better approach than looking at these images of ice sheets and polar bears. So there are lots of different ways in which climate change is impacting our planet right now. And I'm sure you could name many of them for me. You probably see it on TV every day or across your news feed or wherever you get your news from. Everything from heat waves to increased drought and wildfire, inland flooding, coastal flooding, all of these different things. And if you've noticed, it's happening more frequently, right? We're having more frequent extreme events caused by climate change. So the big message up front is two things. One is that climate change is already here. It's not just something we need to worry about for the future, for our children or our grandchildren, right? This is already affecting the health and wealth of Americans as well as people around the world. But the second message is that sometimes when you look at all of this news, it can be, a little depressing, right? And one of the challenges right now is a lot of people are falling for what I call climate doomism, which is that you have this, well, it's really bad and there's nothing we can do about it, so why bother, right? It's such a big problem. I can't make a difference, right? This is what climate doomism is. And my message to you is that while some of these impacts, yes, are very bad, there's actually a lot that we can do and a lot that many people are already doing. There isn't one answer, though. It's not something where you can just, take out your checkbook and write a check and problem solved, right? Wouldn't that be nice? But there are many different ways that we can tackle climate change. And I think that's actually empowering people with the skills that you already have. We need bankers, we need artists, we need real estate agents. We need everyone thinking about how climate change impacts their jobs and what they can do to address this problem, right? So those are my two big messages up front. And then what I usually do, walk you through several images that I'll describe to you now, just to get across this point that the temperatures have been rising and rising very rapidly. And the rate of increase in temperature is virtually unprecedented in the geologic record. When we look back in time, we don't see a time when temperatures rose this quickly. And that's one of the challenges in our world, in the life on it, trying to adapt to this change. It's the rate of change that's the really big challenge. Yes, it's been warmer in the past here on planet Earth, right? But that change happened over such long time scales, it gave things a chance to adapt and migrate and that type of thing. So we can look at lots of different measurements we've been making to track climate change over the historical records when we have instruments where we can measure it. So what I talked about before with those global warming stripes is the global average temperature. We can also, in that context, the last 8 years are the warmest on record over the entire, since the 1880 when we first started making measurements, right? So there's no question that it's warmer now. The most recent data I have for looking at summer temperatures comes from last year, summer of 2021, which was the warmest summer ever on record. And if you're looking at this graph, again, you have just temperatures just skyrocketing upwards. Our summers are getting much warmer through time. At the same time, the atmosphere is getting warmer. The atmosphere is warming the ocean. And we have measurements of temperatures in the oceans too. And you can see there's another image here that shows global ocean heat content. Again, steadily rising upwards over time. 2020 was the warmest year on record in terms of ocean heat content. So I think it's pretty clear based on all the evidence that we have that, okay, climate change is happening. It's happening very quickly, faster than we've observed before. But it's fair enough to ask the question, well, how do we know what's causing this, right? Couldn't it be natural change? I said before that the Earth has been warmer in the past than it is today, which is true. And there are lots of ways that we can look at trying to answer this question. One is to look at all different types of data, either today or back in the past. And we have lots of different tools that we can use to do that. And on this slide, there are images and quotes from two different people who actually wrote op-eds that are really nice summaries of how scientists kind of crack the case on climate change. I like to refer to what I do as a geologist. I'm kind of like a detective of planet Earth. I go around searching for clues of Earth's history, and it's like putting together this puzzle of what happened in the past. So I think of myself like a crime scene investigator, right? CSI Planet Earth, right? This is our latest episodes. And no matter what we look at, right? I would call carbon dioxide is like the world's dumbest criminal because it leaves evidence all over the place that it's guilty for the warming that we're looking at today. And what's interesting is we even use some similar tools, like chemical tools, to what they actually use on those CSI shows. So, we're looking at all different types of evidence, so we can look at these data, and everywhere we look, we understand that these increasing greenhouse gases is really what's driving this rapid rise in temperature that we have today. But in addition to the data, we can also look at climate models. And climate models, we've been running climate models for a long time just to try to understand Earth's past history. And as geologists, we've been studying all the different natural factors that can change climate, because it's more than just greenhouse gases. It's how much of the sun's energy is coming into the Earth at any one given time. It's volcanic eruptions that can shield the sun's energy from reaching Earth that can actually cause a cooling effect. There are all sorts of natural factors that we need to consider in kind of the whole equation when we look at climate change. And so what this slide shows is several computer model runs. When we look at all the natural factors, what it shows temperature would have done from 1880 to present. And it looks pretty flat, although there are a couple sharp dips. Those dips happen when there are big volcanic eruptions like Krakatoa or the really big ones. We have all this volcanic ash in the atmosphere that shields the sun's energy and actually causes a temporary cooling, but then it rebounds again, right? So that's what these model runs look like. And when we compare it to the temperature change, which has been going up, we just can't get the models to match that temperature record when we consider only natural factors. But if we add in human factors, which includes, again, lots of things, not just greenhouse gases, it changes in land use, deforestation, all sorts of different things that we do. Some of those things actually cause some cooling. But what happens is when we run these computer models, the only way we can reconstruct this temperature trend that we have measured and observed over human timescales is when we add in those greenhouse gases that we have emitted as humans. Right, so this shows us not only are we responsible for this warming signal, we're 100% responsible for it. Because I said before, the temperature it looks kind of flat across this time period without those human-derived greenhouse gases. In fact, it shows a slight cooling. So if anything, we should be cooling right now, yet we're warming. So all of that difference is due to us, right? So no matter whether we look at the data or whether we look at models, we understand that climate change today, global warming, is caused by humans. All right, so this leads me to the second half of my talk, which is about the sea level rise part that I study. So this is one of the impacts of a warming atmosphere. It warms up ice sheets that sit on land and glaciers, and that ice can melt and go into the oceans. At the same time, that atmosphere is warming the surface of the ocean, and as water heats up, it expands. And that's actually significant. This thermal expansion of water is enough to cause measurable sea level rise in our oceans. So we have those two things combined that give us this steady sea level rise that we've been measuring. We've been measuring it with great global coverage since 1993 based on satellite data, where we have data from really around the world. Before that, we have to look to tide gauges, which are, point data spread across the globe that goes back in time. But we can look at a combination of those records and we see that sea level is not just rising, but it's been accelerating. Now it's 3 to 4 times faster than it was last century. It's a pretty fast acceleration in sea level rise. And it turns out that most of that acceleration is due to the melting of the ice sheets in Greenland and Antarctica, that they've been losing ice as water, right, melting and running into the oceans. And that has been speeding up. So that's causing this acceleration in sea level rise. We also now understand that the main driver of the observed global mean sea level rise since at least 1970 is very likely due to humans, right? So we also have scientific evidence to point again that this is due to humans, this sea level rise that we're witnessing today. Okay, so what happens when we look into the future? There's a graph on this slide that shows some sea level projections. And so you have these curves that are rising up and then it kind of splays out. You've got a bunch of different curves, right? Which makes it look like we have no idea. It could be this, it could be this, it could be this, right? So you could have sea level going to all these different levels. Why do we have all this range? It looks like we're very uncertain about what's going to happen with sea level rise. One of the reasons is we don't know what humans are going to do. Right? How much greenhouse gas are we going to emit in the future? If I knew that, it would be easier to run the model forward in time. So one of the reasons for all those curves is they are run for many different scenarios of how much greenhouse gas are we going to emit in the future. But there's another big difference. There's one curve in particular on this graph that sits really high. And that comes from a model that has a different physical process in it. Now, this is a challenge for us because we've never been around to witness these ice sheets retreat under conditions as warm as we have today, right? So we don't actually know how fast that process can happen. So we have a limited knowledge of the physics of this rapid retreat of the ice sheets, essentially. And that means that the modelers are still arguing about what physical processes we need in the models, which of these are most important. And that's where I kind of step into this equation and say, hey, we can look in the past and look to past warm periods and see how quickly did sea level rise and how much did sea level rise for a given amount of warming to try to understand how sensitive are these ice sheets to warming, right? And how sensitive will they be as we go into the future, right? And so that's the perspective that I bring to this question. Okay. So one thing that you hear before I tell you exactly what I do with the fossil corals, right? I wanted to say a word about the Antarctic ice sheet, because a lot of times when you hear about sea level rise in the news, you in particular hear about West Antarctica. If you look at the Antarctic ice sheet, I have an image here of the Antarctic ice sheet looking at it from its side. When you look at it from its side, there's a chain of mountains that kind of runs down, not the middle, but runs across Antarctica. They're called the Trans-Antarctic Mountains. And on one side of those mountains, we call that West Antarctica. The other side is East Antarctica. East Antarctica is a lot bigger. When you look at the ice sheet, it's like this huge mass of ice. So you would think we would be most worried about East Antarctica, but we're not. We're more worried about West Antarctica. The reason for that is that underneath the ice sheet, and for those of you on Zoom, the image on the bottom left corner, you're looking at a map of what Antarctica looks like underneath the ice sheet. So this is showing you elevations. And all the areas in this picture that are blue or white are below sea level. So what's happened in West Antarctica, the ice sheet is thick enough, it's pressed down on the Earth's surface, and it's created like a bowl-shaped depression underneath the ice sheet. And so now the base of that ice sheet is actually sitting below sea level. So around the edges of this ice sheet, as the ocean warms, I talked about it as if it's bathing the underbelly of this ice sheet, essentially warming it up. And that can cause it to retreat backwards into this bowl. And once you kind of retreat past the edge of the bowl, there's nothing to stop it from running downhill. So even if we decide, okay, we're going to stop emitting greenhouse gases, we're all going to get skateboards tomorrow, forget about the cars, right? If we're past that tipping point and we're in the bowl, that ice sheet is going to keep retreating. There's nothing we can do about it at that point, right? And this is important for understanding when we're thinking about policy and what we should do in the future and when we should do it. We don't want to reach this tipping point, right? Because then we won't be able, on human timescales, we will not be able to turn that around. Okay, and in fact, what the ice sheet models show, and this is the image on the bottom right of this slide, is that when you warm up the surface ocean around the ice sheet, you lose this part of the West Antarctic ice sheet very quickly. So that's the part that's most susceptible to melting and collapsing, right, in the near future. Okay, so how do I reconstruct past sea level change to give us some insight on these processes? I go to fossil coral reefs around the world because corals have to live near the sea surface to survive. They need the sunlight. And we use that to our advantage to track the position of sea level through time. So we know, I've learned a lot about all the different species of corals and the different things to look at to understand exactly where sea level was above these different corals. And so we can use that kind of as a dipstick of where the ocean was. And I take samples of the coral and I bring them back to my lab here and I date them using a radiometric dating technique, like carbon-14 kind of, but not really, but you've probably heard of carbon-14 dating, right? It's a different set of isotopes, but it's like a clock that kind of ticks through time. And so we can look at the chemistry of this coral to know exactly when it grew. So knowing when it grew and how high sea level was, then we can reconstruct these sea level changes through time. It's not a bad deal because it takes me to tropical islands all over the world, right? All these coral reef places, which with the pale skin that I have is a bit of a challenge to do all that field work. Anyway, okay, so what I want to tell you about is what we've learned about a past warm period that I've been studying, about 125,000 years ago. This is before the last ice age. So the most recent ice age, we had ice sheets that came over Wisconsin. It was called the Wisconsin Ice Advance because many of those glacial features are so well represented here in the landscape that we have. That was 20,000 years ago. So this is before that, there was another warm period. And it's an interesting one because temperatures got to around where we're at today. The poles were a little bit warmer than today and sea level was much higher. And so it's interesting from kind of an analog perspective to say, all right, how high did sea level get and how far did we have to raise the temperatures to get that sea level rise? So I got together with a whole bunch of scientists, people who were ice sheet modelers, climate modelers, people who reconstruct sea level, everyone who's thinking about this question from different angles. And we wrote a summary review paper and we made a cartoon that's on this slide, which shows for several different warm periods, how high did sea level get when we raised the global average temperature anywhere from 1 degree Celsius to 3 degrees? Doesn't sound like a lot, does it? Right? You know, it's like, well, it changed like 50 degrees from last week, right? You know, and it's, what is 1, 2, or 3 degrees? It turns out if you change the whole Earth, by that amount. It's a global average temperature. There's a lot to warm up. It's a lot of heat that you'd have to add. And that has a very significant effect on the ice that's on our planet, right? So it was only about 5 or 6 degrees colder Celsius when this big ice sheet came over Wisconsin. So 1 to 3 degrees can actually do a lot. What we found for this past warm period that I mentioned to you, we call it the last interglacial because it was between glacials. Those are the ice ages, this warm period. The last interglacial, Earth got to about 1 degree Celsius warmer than pre-industrial, you know, what the temperatures were before we started discovering coal plants and all these things, right? So today, we've actually already warmed the Earth by 1 degree Celsius, about the same amount of warming. During the sea level got 6 to 9 meters higher than today. That's 20 to 30 feet, right? If meters don't mean much to you, that's okay. 20 to 30 feet.
So probably
higher than the top of the roof of this building, right? And that's on average. Some places would have been a little higher, some places would have been a little lower. That's an awful lot. And what that's telling us is that the ice sheets we have today are kind of out of equilibrium with this new warm climate that we've heated things up very quickly. It's like taking 2 ice cubes and throwing them into a warm room, right? And now we're standing back and watching what's happening. How quickly are they going to melt and how much are they going to melt by? And for all of these past warm periods that we looked at, we found that sea level rose by at least 6 meters, if not more. So kind of minimum 20 feet or more. That tells us those ice sheets are pretty sensitive to just 1 degree Celsius of warming, but sounds like a small number. And in fact, you heard that I used to live in Florida. I did not live on the coastline. I do study sea level rise, right? But most of South Florida was underwater during this past warm period. And when you look at, if you flooded the landscape today by 6 meters, most of South Florida would be underwater. So you can go back to this presentation and look at a map of what Florida would look like. That's the low end, the 20 feet level, what Florida would look like. The good news, that's not going to happen overnight, right? That would take a long time to happen. But we don't want to get to the point where we're crossing some of the tipping points in the ice sheets that I talked about before, where we're going to get kind of this runaway sea level rise. So one thing that we looked at with some of my colleagues who are ice sheet modelers, we recently published a paper where we combined all this data that we have from these past warm periods that like the one I just told you about. And they ran their ice sheet models to see if they could reproduce the same amount of sea level rise in these past warm periods using their ice sheet models. Remember, I told you they're still trying to understand the physics of this process. So if they can get the models to match these data constraints, then they know they've done something right with the models, and they can take that parameters and then run that model forward in time, which gives us a better estimate of how those ice sheets will respond to future warming. So they asked the question, you know, if emissions continue at their current pace, what would happen to the Antarctic ice sheet? And it turns out they found that the Antarctic ice sheet would cross a critical threshold in 2060, which is not that far away. And sea level would start to accelerate. So instead of millimeters a year, you'd be looking at centimeters a year. We'd cross some of these tipping points that I talked to you about before, these physical tipping points in the ice sheets. Now, how good is that estimate of 2060? Surely there's some uncertainty in the modeling. Could be a little longer until it happens, could be a little sooner until that happens. So what that says to me is that making cuts in emissions now is very important, and not kicking the can down the road. You know, sometimes the politicians or congressional staffers come to me and they say, well, what if we make this commitment? We say, we're going to do this in 10 years. I say, 10 years is not good enough, right? We need to, there's a difference in making those cuts now versus making those cuts in 10 years. The ice sheet will know that difference, right? And this ice sheet melt is already accelerating. We've observed that much, right? So even if we're successful in eventually reducing our emissions and global warming, it's more important that we do as much as we can right now, right? So we can negotiate with each other as much as we like until we're blue in the face about what we should do, but we can't negotiate with the melting point of ice, right? Ice sheet doesn't much care. Okay, so just to wrap up here, because I know we're about at half an hour now. I wanted to summarize what I think are the most important things for you to know about climate change, first of all. And it can be summarized in just 10 words. 5 ideas in 10 words. It's 2 words each. Ready? First, it's real. Second, it's us. Third, it's bad. Fourth, the experts agree. We didn't talk about that a lot today, but the scientists aren't actually debating about whether climate change is happening, right? So experts agree. And number 5, there's hope. And I told you that before, and I saw that reaction. There's hope. Oh, I don't know if there's hope. There is hope, because actually, I told you before, we already have a lot of technologies already in place. There are many things that we can do. It's more a matter of developing the social and political will to do it. That is our challenge today, right? But there are many reasons to be hopeful about it. And I have this quote here from Amanda Gorman that speaks to me in many ways, but also in this context. For there is always light if we're only we're brave enough to see it, if only we are brave enough to be it. And I think that's applicable to climate change as well as lots of other things. So what can you do when you leave here today? I think the most important thing that you could do is to talk to people about climate change. You don't have to be an expert to have a conversation about it. I guarantee you'll learn something in the process of it. And a lot of talking about climate change is actually listening to other people and saying, you know, what is it that you understand, or what are you afraid of, or what concerns do you have? And having conversations about it. People are often too afraid to have these conversations about climate change, but we won't be able to address it until we can, at a minimum, start to talk about it. And that's something that all of you can do. We just missed Thanksgiving. It would have been great topic for Thanksgiving dinner table. You could try at Christmas again, though, if you want to. So, and I did mention this before, my last point is that all of us already have skills that we can use to apply to this problem, no matter what you are and what you've done and what your expertise is. If you're a journalist, an artist, a scientist, a banker, whatever you are, you can address climate change through those skills. So thanks for your attention. I'm happy to take questions if we had some. Hands up over here. Yes.
Yeah, just Wally Brinker used to be a member of our club. He's a professor at UW, and she's one of the first people that came up with the idea of climate change 40, 50 years ago. And then I climbed at Grand Portage, right at Canadian-Minnesota border. There's a hike that goes way up. And you can almost see, on a good day, you can see Isle Royale, but if you look to the land, there's a huge gravel park. I thought to myself, that's got somebody's building a road. But there's trees surrounding this whole thing with this beautiful gravel park. It's way above the lake. I'm thinking, was the lake that high that caused that park, many years ago? And you also have the ridges in York County that show that Lake Michigan was significantly higher.
Right, and it's partly a function of lake levels, how much water was in the lake, but it's also the vertical movement of the land itself. So when the ice retreated from this part of the world, it was pressing down on the surface of the earth here too, a lot. So when you remove that pressure, the land rebounds. It's called isostatic rebound, and it happens slowly over time. And that's the main reason why you get a lot of these elevated shorelines from here northward, where this ice sheet was sitting in the past. Around Hudson Bay, they're spectacular. You can Google these pictures of this stair. It's like going up steps, because that's where the ice sheet was the thickest. So the land is still rising up. And as it does that, if it sits somewhere and the waves cut a shoreline and it raises up again, you basically get this staircase, this terrace effect from that isostatic uplift.
I think we have a question from online.
Question on chat.
Okay.
You can repeat this for the benefit of the Zoom people.
Yes.
Will EV vehicles, electric vehicles, make a significant dent?
Okay, so the question is, will EV vehicles make a significant dent? Yes, everything you do, in fact, will make a significant dent, right? So sometimes people think, well, I can't do anything. It's just this one thing. But oftentimes, progress is nonlinear. So in other countries, when they started to adopt more use of electric vehicles, once they got to the point where the sales of electric vehicles reached about 5% of the total sales, all of a sudden it took off because there was enough demand for the charging stations and so forth, became more accessible, right? With many things, as you start to scale up, it becomes cheaper. People are more likely to adapt into it. Right. And so you might think, well, does it make a matter if I buy one? Yes, it does, because then we'll reach this point, right, where it's easier to scale upwards. And everything we do, I mean, if you look at, many of you have probably heard of Greta Thunberg, right, who is this youth climate activist who did the school strikes, which led to a global youth climate activist movement. Why did she get so interested in climate change? Her mom decided to stop flying because she didn't like the idea of all the carbon footprint associated with flying. So she decided to stop flying altogether. And I think this is something that really Greta noticed and took to heart. And she started to think about, well, what can she do about this? And she decided to go on strike. And here's it's, one person decides to give up flying and all of a sudden we have this global movement, right? So I think it's important to remember, while each individual action might seem small, it can really have a large impact. Over here.
On your study of the corals.
Yes.
Does continental drift affect how you age those things?
So continental drift.
More than that kind of 1,000 years.
Right. Yes. So you can do this deeper in history, but it becomes harder to date the corals for two reasons. One, the particular technique I'm using to date is only good back to about 500,000 years ago. Two, those corals are made of a mineral called aragonite, which is pretty susceptible to getting altered over time as it gets weathered. Doesn't hold up very well. And so this particular method of reconstructing sea level only works well over a certain time window. And continental drift obviously happens over millions of years, right? Yeah.
One of the things I think about is they're talking about sequestering carbon dioxide, shoving it back in the ground. You comment on that?
Right, so the question is about carbon sequestration. There's a lot of talk to meet some of these targets people have put forward of, let's not warm the earth more than 1.5 or 2 degrees Celsius, something like this. To get to those targets is going to require actually not just reducing emissions, but literally pulling carbon out of the air in some fashion. At this point, there are some techniques that have been developed to do that, but none of them have shown promise of being able to be scaled up to the level that we would need them. Many of them are also very energy inefficient, would require a lot of energy themselves and or water in the process of so doing. So that's an active area of research and it's something we should look into, but it's not something we can place our bets on right now in terms of being able to save us, so to speak, right, out of this problem. The easiest thing to do is to cut emissions.
John and then Penny.
My question is, are you familiar with writing with Graham Hancock? Any chance?
No.
He's proposing, I just read 2 books recently. He's proposing that civilization goes back many thousands of years, maybe 10,000 years longer than what we think. And that glacial events, glaciers and the forming and the elimination of glaciers has changed Earth, and that there are places, for example, he took one place that sticks in my mind off of India, where there are ruins 30 meters under the water off of the coast of India. And so his proposal is that this was there prior to when the glaciers were here and the water level was that much lower. So it's interesting writing, I guess.
Yeah, no, there's certainly evidence of ancient civilizations below present sea level. And when sea level was lower, when we had these really large ice sheets on land, because a lot of that water from the oceans was trapped in these ice sheets. So I'm sure there's still a lot to be discovered from that perspective. And looking, because it's not easy to look through the water and see all these things, right?
To Penny and then.
Yeah, I wonder how global warming affects migration, animal life, right? And what's that whole effect on us or and the ocean?
Yeah, so the question is, how does global warming affect animal migration? And how does that impact us? It does definitely, because different organisms have different temperature tolerances, places that they like to live. There are challenges to them being able to migrate because of the way that we have developed our landscape and having, corridors of migration that they can travel through, right? And that's been extremely disruptive. So there are multiple effects layered on here. But there's also the challenge of being able to migrate fast enough, right? So from my perspective, if you look at corals, which are animals, they migrate, basically their larvae float on ocean currents. And so they can, float along and repopulate in another area. And they've done studies about kind of how fast can they move latitudinally to get out of this very hot water in the tropics. And they're not able to migrate fast enough relative to the rate at which we are changing the temperature in those ocean waters. So there are many factors to consider there, but that's certainly a big concern, animal migration, but I would add to that human migration as well. We also have temperature tolerances, and we are already seeing some impacts of climate migrants wanting to move out of certain areas that are drought stricken and so forth to find better land.
Another question from the chat. Do you have colleagues in China and India, perhaps other major industrial countries, who are preaching the same gospel and having an impact, effective advocacy?
Yes, I mean, there's effective advocacy in a lot of different places, and not just from scientists like myself. I think it's important for scientists to have this role, but important for other people as well. But there are also a lot of climate deniers out there too, and they are very well funded by the fossil fuel industry, and they unfortunately occupy a lot of the media space. And so you think that that's a bigger group than it actually is. They're actually really, when you look at surveys of them, like in America, it's far less than 10% of people who identify as really being strong climate deniers. You would think it's like 50-50 or something, right? People trying to debate about it all the time. So that's another reason for me saying, there's hope, because a lot of us actually understand what is going on to different degrees and what's going to happen in the future.
That's not the question.
Well, go ahead then. I was intrigued when you talked about the volcanic ash and how that actually cooled. And I think back to what we've been experiencing, or at least the western part of the country has been experiencing with the fires. And even though it seems counterintuitive, are those fires long enough and frequent enough that it's having to change?
So the pollution that goes in the air from wildfires can have a very temporary cooling effect. It's a net warming effect though, because you've added all that carbon into the atmosphere through the burning. And if some of that that black ash actually ends up in places like we can see on the Greenland ice sheet, that it accumulates out of the atmosphere, then you have that black material on the surface, which warms the surface of the ice sheet more. And they've shown that that's actually having a significant impact on the ice sheet. So net impact is not good, unfortunately.
It was the same true for the volcanic impact too?
For volcanic ash, yes, right, yeah.
So.
Yeah, because volcanoes are emitting CO2 also. So it's a net effect of warming.
So I just wanted to make a comment, and I got a question after that if I can remember what it is. I was telling you that it was really hard to get in touch with you through the phone. You don't have a phone in your office, and you said you do have a phone, but you don't let the number out because you have a lot of climate change deniers that leave harassing messages on your phone. Just want to make that, and that's something. And the question I have, which is also really another comment, is I'd say about 5 or 6 years ago, Bob Lindmeyer, who was a semi-retired weatherman on Channel 27, started talking about climate change. He was, as far as I could tell, he was the only one in the Madison area that on the weather that talked about climate change. And I wondered why the other stations don't do that, or why, when they talk about weather,
Right.
some of them are starting to do that.
Yes. Yeah. So part of the question for those of you on Zoom is about people who are weather people on the news stations talking about climate change and why more of them aren't doing it. So there are more people doing it. And part of that comes out, there's a program from a group called Climate Central. And they actually run workshops to train meteorologists to understand how they can make this connection to their viewing audiences. And they provide them with material. You can go onto their website. I can even download, you know, for the Madison area or for anywhere I want. You know, how have summer temperatures been changing over time? You know, is it just your imagination or is it warmer in the summer here? And they can show that, oh, it's a particularly hot day today. Let me show you how summer temperatures have been changing over time. It's a great opportunity because for many people, this is one of the only scientists that they kind of know and are familiar with, and they're in their living room every day. Right. And it's a really wonderful opportunity to have this communication. And some of them are really doing a wonderful job at it. And so it's been a nice transition to see.
Yeah, Bob Lindmeyer actually has a presentation. He gave it to us on Zoom. If we were still using Zoom. He has a presentation on climate change that was good, I thought.
Yeah.
And it can be used with kids.
Right. Yeah. Terrific.
Dan,
Do you have a card that we can have so we can contact where you?
I do have a bunch of cards in my bag. I'd be happy to share them. Yeah.
Did they have your phone number?
No. Nice try.
thanks so much.
Thanks for having me.
Kiwani, I'm from the UP of Michigan. Ishpeming is the town where it's located, Pioneer Kiwanis Club. And we have 29 members this year. We lost a couple through death, but still doing our projects with building ramps for people that can't afford them. Although the price of ramps double as far as lumber and raw materials. And, we just got done with a peanut day. We still do peanut day in September. We did our own peanuts. And even though the Kiwanis International stopped peanut days. And we're also doing a candy and fruitcake sale starting at Thanksgiving here through Christmas. So that's our two major fundraisers. We work with the ski races and the bike races that are so popular up in the UP, helping out with the stations that provide refreshments for them as they're racing through. Some of them don't stop. And then we're also working with 3 different ski clubs in the area. So those are our major projects. We have a lot of little other ones too. Beautification projects, clean the highway, clean the city, that kind of thing. Good to be here. Nice to hear the talk. I have to go pick up my grandson from school. It's got early out today.
Okay,
Thank you.
thanks for joining us, Dan. Okay, now for a moment of reflection, we have Jerry Schock.
Previous talk kind of reminded me of deniers. And my talk today is about people who lied about COVID-19. This is taken from an article that originally was printed in the Chicago Tribune and was reprinted about the middle of last month in the State Journal. During the height of the pandemic, 4 in 10 Americans misled others about their COVID-19 status or their adherence to public health measures designed to prevent the spread of the virus, according to a study that was published in JAMA. I think you know that magazine, Journal of American Medical Association. Survey was taken from 1,700 adults in December of 2021. 32% of adults admitted they had engaged in some form of misrepresentation related to COVID-19. The vaccinations and compliance with the pandemic protocols. More than 6.5 million people died worldwide from the pandemic, including over 1 million people in the United States, and that's so far. About 18% of those surveyed thought or knew they had COVID, but failed to mention it to those they were with. More than 24% reported telling an in-person contact they were taking more precautions than they actually were. About 21% said they had avoided getting tested for COVID when they thought they might have been infected. I'm thinking of my brother-in-law right now. About 8% told someone they had been vaccinated when they had not. I'm thinking of another brother-in-law. What were their reasons? Complying with protocols can sometimes be psychologically, financially, and physically challenging. People may withhold information so they can attend a health appointment or to allow them to continue to go to work. Some said they wanted to feel normal again or to return to the life before the pandemic. Think of football stadiums full of people. Some said they wanted to exercise their freedom, or it was no one else's business. Some said they were following the advice of a trusted public figure, such as a politician or celebrity. Gargle with mouthwash. Some said COVID-19 was real, but they couldn't miss work or they didn't really feel sick. Who was lying? Those under the age of 60, that's probably none of us in this room, and those who reported a greater distrust of science. We just heard about that in the lecture today. It's possible the survey undercounted as participants may have been lying in the survey. Thank you.
Thanks, Jerry. I found that very timely because I've got to admit, I have not been masking as much as I used to. I've actually gone into some stores without masks on, and I've taken several COVID tests over the last 2 weeks because I've had a I woke up, felt bad, took a COVID test, things got better. And then the last 2 mornings I've gotten up and it just felt horrible. All the COVID tests are negative. So I think because I haven't been as vigilant, I got a cold and an upper respiratory thing. So now I think I'm going to go back to more of the masking because I think my resistance to those type of viruses has gone down after masking for a couple of years. And I don't think the solution is not masking and building up my immune system. It's just being better about masking. So, okay, beyond that, I do not have any other announcements other than I am sorry for this week's announcement where I have I really messed up and missed the date and things like that. So I'm going to do a better job. I'm going to blame it on the head cold. Beyond that, I think Ron has an announcement.
December 4th, we have our Capital Christmas pageant. Oh, okay. The Capital Christmas pageant is on Sunday, December 4th. That's what Kiwanis sponsors that. And I've got the flyer for you to take. We have students that volunteer from the Madison area schools, east, west, not west, for some reason, but east and Memorial and Pollock, Edgewood, and McFarland High School. They perform in the state capitol. There's instrumental and also vocal performances. And Kiwanis sets up a stage. The stage that we have Reynolds move in for us. They start in between years, and stay in one of the galleries so that there's performers up on that stage, but the other vocalists and instrumentalists are on the lower level. But anyway, we always have a pretty good turnout there. I got flyers to take and learn more about it. There are 2 performances, 4:15 and 5:15. So they're not very long, but we do, and we set up chairs there. So if you need some seating, you have chairs that could be fit. But I think we overfill them. So, but anyway, I'll pass all these around if you want. Pick one. Please do.
Thanks, Ron. Jim?
One person asked for a calling card from Andrea Dutton, and she gave me a whole pile, so, well, actually not a lot, but if you need them, want one, I've got them over here.
Please save one for me. Okay. Anyone else have any announcements for today? Dick?
I've got 2. First, I want to explain the LOK for anybody who doesn't know what it is for our 100th. I was going to say our 100th centennial, but that'd be repetitive. So for our centennial some years back, Scott Wallace made this, and it has all of the different activities that he could find that we club had participated in the first 100 years. And so his wife had that, Marty, and when Scott passed away several months ago, Marty had asked me what to do with it. And I said, well, I'll pick it up and bring it. So I picked it up on Saturday after Wilmar, which is my second announcement. So we had Wilmar on Saturday, and we had spaghetti and meat sauce and broccoli, Texas toast, lettuce salad, fruit salad, and we had some holiday cookies that Co brought, and we had some of her homemade cookies, just a few that got past the testing stage. And mostly for dessert, we had pies, apple pies and pecan pies. The Wilmar has a fundraiser every year just before Thanksgiving, and they have these pies that are made commercially and boxed with their name on everything, and they sell those. And they had about a dozen that didn't sell. I mean, they sell hundreds, and so they had about a dozen that didn't sell, and so we distributed those sliced pieces. And we served, I didn't get an exact count, but 36, 37 people. And those who helped out were Penny Nallett and where's Penny? There's Penny. And Tom Broad, Meg Galloway, Bob Rand, Eileen Nelson, Ken Cossack, and Cole Williams. So it was a good day. Thank you.
Is there anything else for the good of the order today? Going?
The blood drive,
Oh,
got everybody?
Well, I'm kind of missing one person. Bob's brother had an accident last night, and he went to the hospital, so Bob may end up not being able to help me out, but it's doing the canteen on the last shift. Want to do it? Yeah. Okay. I was gonna say, otherwise I could kind of handle it, because the last shift's a slower shift than most of them, but if you're gonna be there, it starts at 12:30. Department of the
December,
what?
December 1st,
December 1st, right?
Thursday.
great. If there is nothing else, we will adjourn.
Right.